Hello, and this is the second part of GCSE Maths Mock Paper 1. So let's get on with it. Mark has 18 bags of counters and 12 boxes of counters. That's annoying when they use the same letter for two different objects because you're going to be thinking about bags and boxes here. The mean number of counters in all 30 bags and boxes is 14. The mean number of counters in the 18 bags is 10. Mark says the mean number of counters per box is 4. Is Mark right? Okay, we've actually got enough information to show to find the actual exact mean number of counters per box here, because he's got 18 bags of counters, yeah? And in the 30 bags and boxes, there's 14, on average. But just on the counters, the mean is 10. Yeah, so on the bags, sorry, the mean is 10. So if we just look at bags first, yeah. Okay, what do we know? We know that the sum of the bags, yeah, or sum of counters in the bag, whatever that is, divide that by 18 and you get 10. Oh, well, that means that the sum of the counters in the bags, yeah, should we just call it bags now, is 180 counters. Yeah. Now we know that bags and boxes, so sum bag plus the sum of the box divided by, what is that, 30? Well, that equals 14. Oh, in other words, there's 30 times 14, which is 420 in the sum of the bags and the sum of the boxes. Well, we already know the sum of the counters in the bag, that's 180. And so the sum in the boxes is going to be 420 minus 180, which is 240. And if you divide that by how many boxes there are, 12, 240 divided by 12 is, of course, 20. And so, no, he's wrong. No, it's 20. That's how you can answer that. But you could also answer it in other ways. You don't have to have that approach to it. I quite like the way of, finding a complete solution, really. But yeah, it makes it nice and clear. Okay, right. Proves that the recurring decimal 0.43 recurring is 13 over 30. I saw an interesting approach to this, but I'm going to show you what they expect. But I might even show you afterwards what one student did in my class. It was like, it's quite clever. I quite liked it, but I don't know if they'd accept it. Okay, right. So obviously this equals this, yeah? The standard sort of approach is, I don't know, 10x, try times them by 10, you get 4.333. Now notice, if you do that minus that, it doesn't knock out everything. It's not identical. So this is my approach. There's other ways where you can just subtract those. There's so many ways of doing these. Times it by 10 again, you get 43.3 recurring. So if we just subtract these two, you get 90x is 39, because now they've got exactly the same, and x equals 39 over 90, which is of course the same as 13 over 30. That's one way of doing it. You could just subtract here actually and say that 9x equals 3.9, because you're going to get 4.3 minus 0.4, which is 3.9, and then all these 3's will cancel. One student though of mine actually did the 13 divided by 30 long division, yeah, and showed that it equaled 0.433. Why not? Why shouldn't they accept that? That seems absolutely reasonable to me, but I don't know. I think they want the algebraic approach. So, probably best to use it because that's what they were showing in the mark scheme. Okay, this one. This is typical where people don't see that the word estimate means you can play really fast and loose with the values, yeah? Like, obviously, pi, we're going to have a 3, yeah? The spheres can be radius 2, yeah? And let's make this 1500, yeah? Because it just seems like nice numbers, yeah? Okay, the volume of one sphere is going to be 4/3 times by 3 times by the radius, which is 2 cubed. Now, what does that actually equal? Well, 4/3 times 3 is 4. So you've got 4 times 8, which is 32, yeah? Now, you've got 32 now and 1500. And I'll tell you what, we're just working out an estimate. So let's say 30 spheres, yeah? Because it's much easier to do 1500 divided by 30, because you can just cross out a couple of zeros, do 150 divided by 3, it is 50. That's that's the number of spheres. That's an estimate of the number of spheres they can make. Now, I'll tell you, in the mark scheme, they would have accepted any answer between, where is it? Oh, it's on the next page, 46 and 50. So if you can see, my rather slapdash rounding led to the correct answer. They would have accepted that because clearly this is the obvious way to go for a quick back of the envelope kind of estimation. We're not going too far out there. 2.45 going to 2 isn't bad. Pi going to 3 isn't bad, etc., etc. Okay, if you calculate the number of spheres accurately, how do you think your answer part A will change? Well, this is interesting, isn't it? Yeah. Now, um, you know, so, by the way, in this first part here, I lost count of the number of people who are doing ridiculously complicated calculations. Yeah, it's an estimate, like for 3 marks. It should be nice. Yeah, make the numbers as nice as possible for yourself. Like, even if you think you're being too broad, you'll probably be accepted. They're pretty casual with the acceptance. Anyway, right, we've rounded that one down. We rounded pi down. Yeah, and we rounded this one up. Yeah. Now, what's that going to do to the total number of spheres that you're going to get? Well, the volume of the spheres will actually be larger, yeah, because pi was rounded down. Forget the 1500 for the moment. We rounded that down. We rounded pi down. Yeah, the spheres will be bigger as we rounded pi and 2.15 down. And bigger spheres means if you've got just a certain amount of metal, you're going to be able to make a smaller number from the given metal. Yeah. This means we'll be only making a smaller number. Hope that makes sense from the given metal. Cool. Right, what's next? What have we got? Apologies for that awful handwriting. Hey. Okay. 15. Right, I can barely read that. I'm going to have to find that on the screen next to me. Hang on a second. Is that the fourth root of 27 times 3 to the power times 3 times 10 to the power of something? I just need to find that. Okay, I think it's to the power of 8. Cool. Let me just write that down for you. So we've got to find the value of this without a calculator. Yeah. Now, the most successful people immediately realize we'll find the fourth root of 81, yeah, which is good because that is a power of 3 to the power of 4 is 81. And then 10 to the 8. This is the bit which people don't like, yeah. The fourth root of 81 is 3. And the fourth root of 10 to the 8 is actually 10 squared, yeah, because 10 squared to the power of 4 is 10 to the 8. And so, obviously, 10 squared is going to be the fourth root of 10 to the 8, if you see what I mean, because that means to the power of a quarter. And so it's 3 times 10 squared, which is 300. Okay, this one was 216 over 1,000 to the minus 2/3. There's always one of these in here. They love this question. Okay, minus flips it. Why not do that first? Sorry, it's 1,000. Do that first. Flip it first. Get rid of the minus. Now, cube root it if you like next, because that means cube root. And then square it, and 10 squared is 100, and 6 squared is 36. I suppose we could cancel that down to 25 over 9. Done. Next one. Okay, make t the subject. Well, these ones, you always times this across, multiply it out, and then you match up, because we're making t the subject, you match up the t's. Yeah, put all the junk you don't want on the other side. So I'm going to make this kt minus 2t, so I'm moving that over there, equals 3k plus 6. And therefore, factorize out the t, k minus 2 times 3k plus 6, divide it across, t is 3k plus 6 over k minus 2. Yeah, by the way, if you had minus 3k minus 6 over 2 minus k, that is also correct. But yeah, okay, next one. Factorize this. Students don't like this, yeah, but all you're really doing is like 3 times smiley face squared minus 2 times smiley face, yeah? What does it equal? Well, it equals smiley face times by 3 times smiley face minus 2, yeah? I'm factorizing here. This object can be anything, smiley face, x, or these brackets x minus y squared. So the way you factorize it is take out the x minus y, then you need to times that by 3x minus y minus 2. And so the final answer should be x minus y, 3x minus 3y minus 2. You can leave those brackets in there if you like. But that's it, it's fully factorized. Okay, the next one is completing the square. So if I've got x squared minus 6x plus 1, I halve the middle term. Now I think about what that equals squared, and I take it away. Every time that will be a minus, and then I've still got a plus 1. What you'll find is that bit is exactly the same as this bit, if you see what I mean, and then the plus 1 is on the end, and that will always work if you use the trick of completing the square. So that gives you x minus 3 squared minus 8. And then we can just write down our values of a and b. Now careful not to change the sign. Did they account for the minus? Yeah, they accounted for both negatives, so these are positive. But the minimum vertex is going to be at 3 minus 8. Yeah, that's just a rule. If it's ever of the form x minus a squared plus b, then the turning point is at ab. Yeah, and as this is minus 8, that needs to be, minus 8. Yeah, learn those facts about completing the square. You just want to know them. Okay, this one, we need to rationalize basically a lot of stuff. Now, I mean, whenever I see a fraction within a fraction anyway, the first thing I want to do is get rid of the fraction within a fraction. So the first thing I'm going to do is times by root 3, top and bottom. Yeah, that's going to give me 4 root 3 over, now root 3 times 1 over root 3 is just 1, and root 3 times root 3 is just 3. So I've got 4 root 3 over 4, and that is the same as root 3, and it's done. Okay, this one we're just plugging minus 4 into g. So g of minus 4, notice I'm telling the examiner what I'm doing here, is minus 4 squared plus 2. So that is 18. GF of x, oh, show this, right. By this point of marking, I've become really rather upset by some of the answers I'd seen, and it only ever makes me mark harsher, but it really annoyed me if somebody didn't start by writing g of x equals. I was irrationally harsh on this, but it just really annoyed me. Start by writing that down, because you want that equal stuff, equal stuff, equal stuff, equals, oh wow, the answer they told me to prove, and then you can write as required or something like that. But we need to just plug f here into x here to replace that, because we're plugging, this means plug f into g. And so we've got to do 2x minus 3 all squared plus 2. Yeah. Now we can multiply out those brackets. Draw a little grid if you don't like this bit. Like if you find this bit quite tough. I definitely did all the way through my GCSE and A level. 4x squared minus 6x. Apologies if my handwriting's bad. It's because my fingers are so cold. I'm in a cold shed. Okay, minus 12x plus 9 plus 2. And so we get the right hand side now. And there we go. That's it, done. You can even finish your proof off with a little coloured inbox. Apparently that's one thing you can do without actually writing as required. Okay, so here we go. We've got a vectors question. Now, firstly, for those of you who just kind of tried to blag this and say, well, I can see that's basically half of that. And so you said, so k is a half. Well done, but they wouldn't give you any marks if you didn't use a vector method. So I'm glad you could just see the answer. I really am, but because it's a way of checking it, and it's never a bad thing to do that in vectors. You can kind of look at it and think, oh yeah, it does work. But you've got to use vector method. So OA is A and OB is B. Okay, right, fine. So to do this, I'm going to find BM first. Yeah. And to find BM, I need to write down a few things. Yeah. Because as this is a parallelogram, we can immediately say, BC equals A as well. And BD is going to be the same as B. Because they're just exactly the same lines. Helpful to write it on the diagram, actually. And so what's CD? Well, CD is going to be minus A plus B. You pretty much always do that step in these questions. You probably notice that. And now I can write down what CM is. And the reason why I want to get from C to M is because then I can easily get from B to M. So CM is half of this. And so now I can write down BM, which is what I was aiming to do all along, because once I've got BM, I can see how it relates to OC. Now remember, OC is pretty easy to do because that's a B and that's a B. So we already know, maybe I should have said this at the start, that OC is just A plus B. Yeah, so it will be easy to compare BM to OC in a minute. Now BM is going to be A plus, and that A comes from, yeah, maybe I'll really show the examiner I know what I'm doing. BM is BC plus CM. That's all I'm doing. And so BC is A, CM is half of all that. So, and we can of course simplify this. A minus a half A is just a half A, and then you've got a half B. And now you've proved that lambda must be a half, or K, sorry, it's K. Hence, K equals a half by inspection. I'm just looking at it and I can see that that's exactly half of that. Okay, the length of a rectangle is the same as it. Yeah, this is not as bad as it looks. It really isn't. Yeah, draw a couple of pictures. Right, that's our square. And the length of a rectangle is the same as the length of a square. Okay, but the length of the rectangle is 4 centimeters more and 3 times the width of the rectangle. Let's put X and W here. Well, what have we got to do to the width? We've got to do 3 times the width plus 4, and that gives you the length X. And so I can rearrange that, can't I? And I can say, okay, oh, I can now use, sorry, I can rearrange that though, that's certainly true. But let's look at the next fact. The area of the square is 66 centimeters squared more than the area of the rectangle. So we can say that x squared is going to be equal to xw plus 66. Yeah. Now this question had like a weird mark scheme where you had to get that far to get the first mark, and I thought that was pretty harsh, like in some ways, because it was actually quite hard. Then the next mark as well came from elimination. So obviously we can easily rearrange this. Now what do we want it all in terms of? Well, it'd be handy if we could have it all in terms of x. So if I could point out that w is going to be equal to, because we want to find the length and the width of the rectangle, don't we? Yeah. So here's, yeah, actually I'm just trying to think what would be probably easiest actually if we just chuck this in to x there and there. Yeah, but you can do it the other way and you can solve the quadratic in w instead. It doesn't make any difference. But this looks like slightly easier because you don't have any fractions. 3w plus 4 times by w plus 66. Okay, so multiply these out. Once again, draw a little grid if you're not too confident with multiplying out, you know, because don't mess up the multiply out. 9w squared, 12w, 12w, and 16. Okay, so 24w plus 16 equals 3w squared plus 4w plus 66. Yeah, so there's some algebraic understanding in this, but you get 6w squared, dealt with those. You might just cross them when you've done that. 24w minus 4w is 20w, and this is going to give me a minus 50 on the end equals 0 because I want my quadratic to equal 0. That's the way I solve these. Now I'm just halving everything because I think this is on the non-calc, isn't it? Yeah, and so yeah, you're at the mercy of understanding quadratics here. 3w and w, and now how can we have this to make minus 25? Well, if I have a minus 5 here and a plus 5 there, I think that multiplies out nicely because that's going to give me minus 5w plus 15w, which is a 10w. And so what do I see from this? I see that w equals 5 over 3 or w equals minus 5. Now, you can immediately exclude that because it's a width. And so the width is 5/3. Now, to find the length, we're just going to have to look for an earlier relationship between w and x. Why not use this? 3 times 5 over 3 plus 4. Yeah, so they're really testing your arithmetic in this paper. I quite like this paper. I thought it was fair. 5 plus 4 is 9. I thought it was a decent level of difficulty to compare it to a real thing, because I promise you the real thing will be difficult as well. It has been for the last 3 years. It really has. So get ready for a nasty paper. That's all I'm saying, which is fine. You know, you do the right tactics. A nasty paper can be to your advantage. Okay, right. This is hard. You know, this is the kind of thing you might ponder for 5-10 minutes easy before you think, oh, hang on. But what the best way to do it is to drop a perpendicular. Yeah, and draw this on the diagram, because markers can see your diagram, yeah, and they'll look at it, and there's many times in the mark scheme when you'll see refer to diagram if they've done, if the student has done a diagram. Like, it's definitely fair enough. Okay, if we call this, I don't know, C and D, yeah. So if you like, write this down. Let C and D be foots of the perpendicular. That's what they call it. Be foots of the perpendicular. For triangles AXB and ABY. Now, you don't have to write that. It's a bit sort of flashy or whatever, but main thing is draw something like that on a diagram. They'll give you the benefit of the doubt. They really will, because this is a difficult question. And what they do is if they see somebody do it and, it's clear they know what they're talking about, they start giving you the benefit of the doubt. So, right, with that in mind, right, what can we say now? Now, as the areas are equal, we know CY equals XD because the area of both equals a half AB times CX, or, well, yeah, let's make this clear because I'm basically saying CX could be in there or XD could be in there, but it also equals a half AB times C. Oh yeah, what have I got? Why have I got CX there? Sorry, CY, but that's also the same as XD. Yeah. Okay, that's why I can say CY equals XD, because the area equals that, but it also equals this, and a half AB up in both equations. Hence, you can immediately deduce that CY is XD. Now we know that height is the same as that height. What we can really easily do now is use something like similar triangles or something like that, or congruent triangles, because that triangle must be, that angle must be the same as that one. Yeah. Okay, we've got that. We know that this side is the same length as this side. So we've got side and angle so far. And now, do we know that is the same length as that? Not really. But we do know that that is an angle, yeah? And if that's angle, let's call this like A and A, this must be 90 minus A, therefore, yeah? And so really we've got three angles and a side, and that's certainly enough to deduce congruency, yeah? You could argue like that. The other way you could argue is, I mean, I actually did. You can do this for sine rule actually, like by using sine rule for the top triangle and sine rule for the bottom triangle. But there's no need. It shouldn't be like that really, because there's no need for that. But yeah. So anyway, what are we going to write down? I'd probably write down something like this: triangles CYM and MXD are congruent by AAS, since CMY equals XMD. That's the angle. Yeah. You can justify that by pointing out they're opposite. Opposite angles are equal. And then we just need the side. We already know that CY equals XD. That's side. That's your angle. Now we just need one more angle, a corresponding angle, and we can use the right angles. So YCM is MDX. Both right angles. Yeah, so you can see the triangles are absolutely identical, and hence MY, because the triangles are congruent, must equal MX, and M bisects XY. Yeah, so XY must be bisected by AB. It's cut in half. XM and MY cut in half. done. Okay, hope you found that useful, and keep up the good work. Bye bye.